Hi everyone, in today's lesson we're going to be factoring GCFs, which is known as greatest common factor. This is Mrs. Pagam working with you, so let's go ahead and get started. Alright, our focus today is just greatest common factor. So what is GCF? We already wrote it, but let's write it again. It is the greatest common factor, so it's something that all terms have in common that we can actually pull outside. And what is factoring? Well, factoring is a way of organizing an expression. So we are going to be organizing these expressions in a certain way, and we call that factoring. All right, so let's go ahead and look at example number 1. The first couple, I'm going to go ahead and I'm going to expand these out so you can kind of see what the factoring is going to do. So for example, in number 1, it says factor the following expressions. So I'm going to rewrite all of these in its simplest form. For example, 6 is 2 times 3. And x to the third means I have 3x's and 1y. Minus, I'm going to break down the 8. Well, I know it's 4 times 2. But I also know that 4 can be broken down more to 2 times 2. So I'm going to break that down to 2 times 2. So 2 times 2 is 4, times 2 is 8. X squared, y squared, that's 2x's, 2y's, plus. Break down the 10, so it's 5 times 2. And there's 4y's and 1x. And what we do is take out what they have in common. So first I focus on the numbers. For example, I have a 2 and a 3. 3 2's, a 5 and a 2. So I know that each one of them has a 2 that I can go ahead and factor outside. Nothing else in common, so I leave the numbers alone. Then I go ahead with the variables. Well, I know that I have 1x here. That's the smallest number, so I can only take 1 out. Because I can't ask for this one to give me 3 when it only has 1. So 1x comes out. Then I look at the y's and I see that I have 1y here, 1y here, and 1y here. And that's the greatest I can take out, so that's y. And everything else stays inside of the parentheses. So here's what it looks like. I'm going to go ahead and open the parentheses. Now these are gone. So if you reevaluate what this expression is now, it's 3 times x squared. 3 times x, which we know that we can write as x squared, which we'll do in the next step, minus. Then we have 2 times 2, we have an x, and we have 1y, so we'll keep that there, plus, we have a 5, a y, and then we simplify this, and we get 2xy on the outside, that's the GCF, 3x squared minus 4xy plus 5y to the third. So all I did is combine and put those back together. So 2xy is our GCF, greatest common factor. That's what each term had in common. Alright, now this gets really long and tedious, but I am going to do this one more time as I showed you, and then we'll kind of go ahead. So I'm going to break down the 4 to 2 times 2, g squared to g times g, and a p, plus this 4 to 2 times 2, this g, and 1p. Alright, I'm going to circle what we have in common and pull them outside. So I have 1, 2, 1, 2, so a 2 comes out, another 2 and another 2, so another 2 comes out. Excuse me. A g and a g, so 1g comes out. A p and a p, so 1p comes out. And what I'm left with is a g plus nothing. Now, there's always a placeholder because you can't just make it look like that. That looks awkward, so you got to put a 1. And we have 4gp times g plus 1. And once again, that's factored, and 4gp is our greatest common factor. Alright, let's head on to number 3 and number 4. Now let's try to do these without expanding out so much and just kind of ask ourselves, what do they have in common? Alright, the number 9, 18, and 3 definitely have a 3 in common that we can factor out. And then y-wise, I have 3 y's here, 2 and 1, so the most I can take out is just 1. Now, in my head, what I'm doing is I'm dividing this by 3y. 9 divided by 3 is 3. And then the y's cancel out, so I'm just left with 2y. Plus, let's divide by 3y again. 18 divided by 3 is 6. And y's cancel out, so I'm left with just 1y on top. Minus 3y divided by 3y is just 1. So this ends up being my expression. Now, if you are having a hard time seeing that, maybe expanding it out for the next couple ones is a good idea for you. Alright, let's look at number 4. We're going to do the same thing. 80, 15, and 45. What do they have in common? Well, I think they each have at least a 5. So I'm going to go ahead and factor out a 5. And then I know that they have, this one doesn't have a's, so I can't take out any a's. But each one of them have at least one x. So I'm going to take out a 5x, see how that works out for me. Alright, I'm going to divide each one, and I usually do this in my head, but I'm just kind of showing you, each one by 5x to see what I'm going to get. Alright, so let's simplify. 80 divided by 5 goes in there 16 times. And then we're left with x to the 4th because one of the x's is out. Plus, 15 divided by 5 is 3. And we're left with 2 x's because one of the x's is out and all the a's are still in. Minus 45 divided by 5 is 9. And we have x's are gone and just an a. Now, I like to double check, make sure 16, 3, and 9 don't have a number in common. And if I think about it, they really don't. I was thinking maybe I could factor out a 3, but 16 divided by 3 is not a nice number. So this ends up becoming our final answer. Alright, we're going to go ahead and do the rest of these in class, but thank you for watching the video. If you're still struggling, go ahead and just kind of re-watch. Alright, great job today.